moment the crust finally stood still. There was a time when survival itself seemed impossible, when fire ruled the surface and the ground never stopped moving. And yet, Earth endured what should have erased it completely. Long after oceans formed and chemistry began to organize, the planet entered one of the most violent phases of its existence. This matters because survival was not guaranteed. Even after all that progress, Earth faced forces powerful enough to reset everything back to molten chaos, and many worlds likely did not make it past this stage. What allowed Earth to continue is the reason it still exists today. The difference between a planet that endures and one that is consumed by its own interior comes down to structure, timing, and the slow accumulation of resilience. Deep within the planet, heat built relentlessly. Radioactive elements decayed, releasing energy that had nowhere to go. The mantle churned constantly, dragging the crust along like fragile skin stretched over a boiling interior. Volcanoes erupted across the surface, not as isolated events, but as a global condition. Fire was everywhere. The landscape was rewritten repeatedly, with entire regions resurfaced by lava flows that buried whatever had existed before. At the same time, the solar system remained hostile. Large bodies still crossed Earth's orbit, colliding with enough force to melt entire regions of crust. Impacts triggered massive eruptions, darkened skies, and boiled oceans locally and sometimes globally. Each event tested whether the planet's fragile balance could survive another shock. The bombardment was not constant, but it was unpredictable, and any single impact carried the potential to undo millions of years of progress. What made this era different was not the violence, but the response. Earth no longer shattered randomly. Its layers absorbed energy, redistributed heat, and adjusted instead of collapsing. The crust broke, moved, and healed. The oceans boiled, cooled, and returned. Systems that had taken billions of years to build bent without breaking. This was Earth's trial by fire, and passing it required more than luck. It required structure, feedback, and the ability to change without starting over. The planet was learning how to survive its own hell. The pressure did not ease with time. If anything, it intensified as Earth's interior continued releasing energy faster than it could escape. Massive lava flows resurfaced entire regions, erasing landscapes repeatedly before they had time to stabilize. The sky filled with ash and gas, blocking sunlight and plunging the surface into cycles of heat and darkness that lasted for years at a time. Yet beneath this chaos, something remarkable was happening. The planet's internal dynamics were no longer random. Convection currents in the mantle followed persistent paths, driving the movement of crustal plates instead of tearing them apart indiscriminately. This motion allowed heat to escape gradually through spreading ridges and volcanic chains, preventing the buildup that could have torn the planet open. The mantle had developed a circulation pattern that balanced energy release with structural integrity, and this pattern would become the foundation of plate tectonics. Oceans, once fragile, became shock absorbers. They absorbed enormous amounts of heat, redistributed it across the globe, and softened the effects of impacts that would have sterilized the dry world. Even when surface waters boiled away temporarily, they returned through rainfall and condensation, preserving the planet's long-term balance. Water was no longer just present. It was essential. The atmosphere evolved alongside these changes. Volcanic gases altered climate repeatedly, triggering periods of extreme warming followed by rapid cooling. But instead of spiraling into permanent collapse, Earth began regulating itself through chemical feedback loops. Carbon moved between air, water, and rock, stabilizing temperatures over long spans of time. This carbon cycle became one of the planet's most important self-correcting mechanisms, quietly preventing the kind of runaway heating or cooling that could have rendered the surface permanently uninhabitable. What emerged was resilience through repetition. Catastrophe became part of the system instead of an ending. Each disaster tested the planet's limits, and each recovery strengthened the structures that made survival possible. Earth was not escaping its hell. It was adapting to it. This adaptation came at a cost. Stability did not mean peace, and survival did not mean safety. The planet endured long stretches where conditions pushed every system to its limits at once. The sky darkened under thick clouds of volcanic gases. Temperatures spiked and crashed unpredictably, and the surface reshaped itself faster than memory could form. During these periods, Even the earliest forms of life faced near total annihilation. Any fragile chemistry or emerging biological process was exposed to intense heat, radiation, and chemical disruption. Many experiments ended before they could leave a trace. But not all of them. Some found refuge in the depths, shielded by water and rock. Surviving where the surface could not. These deep sanctuaries became critical, preserving the thread of chemical complexity through episodes that would have otherwise severed it entirely. Deep oceans and subterranean environments became sanctuaries. There, heat arrived gradually instead of catastrophically, and chemistry remained active without being constantly erased. These hidden systems preserved continuity during the worst episodes, carrying complexity through times that would have otherwise reset the planet entirely. Meanwhile, tectonic motion continued reshaping the surface. Continents formed, broke apart, and reformed, altering ocean circulation and climate in slow but profound ways. Each rearrangement forced the planet to adapt again, testing whether its feedback systems could maintain balance under new conditions. The geography of Earth was never fixed, and every new configuration brought new challenges and new opportunities for the systems that depended on stability. This was the emotional peak of Earth's survival story, not the violence itself, but the persistence that followed it. The planet was no longer fragile, but it was never safe. Every gain came with risk. Every recovery carried the possibility of failure. And still, Earth endured, not because catastrophe ended, but because resilience had become embedded in the planet's very structure. The climax of this era was not a single disaster, but the realization that Earth could no longer be easily erased. After enduring repeated cycles of extreme heat, impact, and internal upheaval, the planet emerged fundamentally changed. Its systems were now interconnected, each one buffering the others against total collapse. Destruction still arrived, but it no longer had the power to reset everything at once. As volcanic intensity slowly declined, the surface gained longer periods of calm between catastrophes. Oceans deepened and stabilized. Atmosphere and climate settled into patterns that could last for millions of years instead of moments. The crust thickened, providing insulation that moderated the planet's internal fury. Earth had not become gentle, but it had become survivable. The resolution of this chapter lies in what did not happen. The oceans did not vanish permanently. The atmosphere did not escape into space. The crust did not fracture beyond repair. Each near ending reinforced the systems that prevented the next one from becoming final. Survival became cumulative, each crisis leaving the planet better equipped to handle the one that followed. This endurance shaped everything that followed. Life, once it gained a foothold, would inherit a planet already trained by catastrophe. Adaptation, resilience, and recovery were written into Earth long before they appeared in biology. The planet itself became the first survivor. What Earth endured was not a curse. It was preparation. The same forces that nearly destroyed it also forged a stability that allowed complexity to grow without being erased. Subscribe to join the journey.